Hi, my name is Vihaan Pardeshi, and I'm going to be showing you guys how to solve this differential equation over here. So if we just take a look at this, uh, you guys can see that we can't really separate this by parts uh, and solve it that way, like not by parts, by variables. So we can't get all of the y's and the t's, I guess, on one side. And so this is where integrating factors come into play. And so this is the formula for how to find the integrating factor for a differential. And so this is kind of just the general one. So dy by dx plus some coefficient of y is equal to q of x, which is basically just another term. So taking a look at this problem over here, we can see that in this case, y, also by the way, y prime can be just rewritten as dy by dt. And so in this case, 3 is p of x, right? Since it's just the coefficient of y, that's kind of what our p of x is. And so our integrating factor for this becomes e to the integral of 3. And since we're dealing with t as the other variable, it's the integral of 3 dt. And so this just becomes integral of 3t. And so that is what our integrating factor is. And so once we find that, we can basically rewrite this left-hand side as d by dt times e to the 3t times y. And so what we've done is basically we've taken this side and we've rewritten it like this. And since we multiplied the other side by that, we also have to do the same thing on the right hand side. So we get this term stays the same, but we multiply it by the integrating factor. And then so once we have this, we can basically multiply this dt to this side. So we end up getting d e to the 3ty, and then this whole term, 3 plus e to the negative 2t times e to the 3t dt. And then from here, we can actually just integrate both sides now. So on the left-hand side, the d and the integral kind of just cancel, so we're left with e to the 3ty. And then on this side, we have to evaluate this entire integral. So we can multiply it, so this kind of becomes the integral of t e to the 3t, right? Just multiplying this to this side. And then e to the negative 2t times e to the 3t gives us plus just e to the t, right? And then all this dt. So for this term over here, we can use by parts, or what I like to use is the tabular method. So we kind of just take t, find the derivative, and then the other derivative. And then on the other term, we have e to the 3t, find the integral of it, which is just 1/3 e to the 3t. And then the integral of that, which is 1/9 e to the 3t. And we kind of just multiply these two, alternating signs. So this is just a faster way of doing by parts. So we get 1/3 t e to the 3t, and then this a minus, so minus 1/9 e to the 3t, and then this just stays plus e to the t. And then there's also a plus c, because we are integrating without any bounds. And then once we have this side, so this is equal to this term over here, e to the 3t times y. And then once we have this, all we really need to do to solve for y is just divide by e to the 3t. So this kind of cancels. We can divide through. This is over e to the 3t, and then this is also over e to the 3t. So this ends up becoming t over 3, this term, minus 1/9. This simplifies to plus e to the negative 2t, and then plus c times e to the negative 3t. And that's the final answer to the problem.